Hi everyone, this is Asha. I'm working as an assistant professor in the Department of Artificial Intelligence and Data Science. In this series, I'll be teaching the subject Design and Analysis of Algorithms. Each video will cover one topic in a clear and simple way. Let's get started. Hi students. So our topic is Design and Analysis of Algorithm. See, before getting into any topic, first of all, you should ask 3 questions or 3 words to yourself. First one is what, second one is why, and third one is how. So, if you can able to answer for these 3 questions, then you are clear with that concept. Okay, so whenever you study, please use these 3 questions and based on that you study. So, what means it will define the concept? Why means it will explain the importance, and how means it will describe the process. Fine. So now our topic is design and analysis of algorithm. See here my question is, why do we analyze an algorithm? We are writing an algorithm, right? So already an algorithm is written, but why I have to analyze it? See, we analyze an algorithm to understand how efficiently it solves a problem, okay, in terms of time and resources like memory. So now let us get into the topic and I'll explain you what is algorithm, why we have to write an algorithm, and what is the importance of algorithm. Why can't we write the program directly? Why we have to write algorithm first, then the program? All these things. So shall we start? So now my question is, can I write a program without writing an algorithm? Because only if I write an algorithm, I have to analyze it, right? So why shouldn't I write a program directly instead of writing an algorithm? Yes, you can write a program without writing an algorithm first, but it's not a good practice. Let us understand why. Okay, an algorithm is the plan, but the program is the implementation. See, in simple words, I can say an algorithm is like a blueprint, a step-by-step plan to solve a problem. But a program is like the actual code which you are going to execute in a system. So it can be either in C or Python or Java, which is going to implement the plan. So if you skip the algorithm, what will happen? Your coding will not be with a with a clear plan. Suppose you just imagine you are going to construct a house without a proper blueprint, how it will look like. So then and there you will keep on changing, right? The plans will be changed. So that's why a blueprint is planned first, then based on that the construction will proceed. Likewise, before writing a program, you have to write an algorithm. So based on the algorithm, the program will be written. Got it? Okay, usually how will we write the algorithm? See, we will write in simple words, right? We'll use general English like start the process, or start, read the numbers, accept the numbers, perform addition or subtraction or whatever may be, then display the result and stop the process. See, if we write an algorithm like this, when I'm trying to convert that algorithm into an equivalent program, it will be very tough for the designer. Okay? Because why do we write an algorithm? Because we are reducing the time of the programmer. If an algorithm is defined properly with proper terms and proper logic, when the programmer is trying to convert that algorithm into an equivalent program, then it will be very easy. Because it is common for all language, right? So based on the language, the corresponding program can be generated. So an algorithm should not be so simple. It should have the logics properly with the proper statements. So it should not be like a simple language. Got it? What will happen if you skip the algorithm? Directly if you start writing the coding, what will happen? See, you may make logical errors, and the program may become inefficient, possibly messy or unreliable, without a proper design. If you are building a house without a proper design, what will happen? So same thing will happen to your program. and debugging, everything is tough, right? So always we have to design it properly, then we have to convert into an equivalent program. So we have to give importance to an algorithm. So we can write a program without first writing an algorithm, but writing an algorithm first makes the program clearer, correct and efficient. Because while you write the algorithm itself, we'll decide the logic and as well as the syntax and what are the variables we are going to use. Everything will be defined over there. So it will be easy when you're converting that algorithm into an equivalent program. Okay? So now, why do we analyze an algorithm? Because to measure the performance. See, we find how fast an algorithm runs, that is the execution time. We check how much memory it needs, the space requirement, and to compare different algorithms. For example, if I want to perform a linear search or if I want to perform addition, then I may write several algorithms. But from that, I have to choose which algorithm is best. So in order to compare also, I can use the analysis. For the same problem, multiple algorithms may exist, right? And analysis helps us to choose the most efficient one, to predict the scalability. And analysis tells us how performance changes when input size increases. See, if the input is very small, how the performance of the algorithm will be. If the input is large, how the performance of the algorithm will be. How about the time, all those things. So an algorithm that works fine for 100 inputs may become too slow for 10,000 inputs. So it all depends. So we have to ensure that feasibility, and some algorithm may be theoretically correct but impractical because they take too much of time or memory. So to guide improvement, by knowing which part of an algorithm is costly, we can optimize it. So based on what we choose an algorithm, so the two main aspects are time complexity and space complexity. See, it measures how much time an algorithm takes and input size grows. That means based on the input, how the time varies. That is first one. And measures how much memory the algorithm uses. Got it? I'll just show you one example, like how we have to choose an algorithm. See here, I have displayed three algorithms. One is bubble sort, another one is merge sort, another one is quick sort. So when you see the time complexity of bubble sort, it is O of n square, and merge sort is O of n log n, and quick sort is also O of n log n. Okay? So that means which is very slow, n square is very slow, and n log n will be faster, and quick sort is also, it will be faster or it will be like average. So based on the time complexity only, we have to select an algorithm. Because why do we write a program? In order to execute something. At the same time, it should be fast, right? So we have to save the time. In today's world, we have to do the things in very fast manner. So that's why we are going for time complexity. So though we have several algorithms for a single program, we have to select an algorithm which has less time complexity. That means it should be faster. Then that particular algorithm will be converted into an equivalent program based on the user's need. It can be like C program or Python or whatever may be. Already I told you an algorithm is common for all the language because it is like a step-by-step procedure or instructions which we are going to perform. Later that algorithm can be converted into a program. So that's why we have to concentrate more on algorithm first. Once if it is designed properly, then it can be given to any programmer so that they can convert into a program according to their language or necessity. Got it? Suppose if I am selecting an algorithm irrespective of its time complexity or space complexity, what will happen? How my program will get affected? See, my program may become very slow, or it may waste the system resources and poor scalability, then bad user experience. It may experience something, right? Because if it is not properly designed, you may face any type of difficulties, and it will be difficult to fix later. Later in the sense, after implementing it as a program, it's tough to fix. So that's why we have to choose an algorithm based on the time complexity. Because again I'm telling, because for a single program, for a single problem, we have many solutions. How do we choose a solution? Based on the time complexity. Fine. So now we can ask the question to ourselves, why do we learn design and analysis of algorithm? See, this is to think logically and step by step. Then we can write programs that are not only correct but are also fast and efficient. Then we can compare different methods and choose the best one. Then we can build the foundation for advanced topics like machine learning, artificial intelligence, data science, and cybersecurity. Okay? I can show a small difference between a normal programming and now a design analysis of algorithm. See, it will just focus on writing the coding alone. But here, how to write an efficient code. Okay? So when you write normal code, you will just concentrate on coding alone when you're normal programming. But when you're concentrating on algorithm, you can create an efficient code. Then normal programming, it is concerned with getting correct output. But here, not only correct output, but it is also bothered about how fast and how much memory it uses, because we are concentrating on the time and space complexity, right? And third point, we implement small problems. But here, when you use analysis of algorithm, that is when you analyze an algorithm, you can solve complex real-world problems using logical design. And when you write a normal program, you will concentrate only on syntax. But here, we'll concentrate on logic, structure, and most importantly, optimization. So what do we learn in this subject? Do we write programs or only dealing with the algorithms? We do both. We do algorithm design. That is, we write step-by-step logic, which is language independent, as I mentioned already, and program implementation. We can convert the algorithm into an equivalent program. That program can be Java, Python, C, or anything. So, for example, an algorithm means I'm just writing a steps to perform binary search. And now I will write a program based on that algorithm, and I can execute that binary search by giving my own data. So first we design, then we analyze its performance, and finally we will implement it. Now it's time to learn about its applications. How is this subject useful in our real life? See, DAA concepts can be used everywhere, like search engine. Google uses efficient searching algorithm. Then route finding, Google Maps. It uses shortest path algorithm. Then comes your e-commerce recommendation and sorting algorithm. Then cybersecurity, encryption algorithm. And finally, data science and artificial intelligence, optimization algorithm. So these are the applications of DAA. So why do we need algorithm? We need algorithms because they provide a clear step-by-step method to solve problems efficiently, accurately, and consistently. Thanks for watching.